Hello, this is a video about the world's largest hydrocarbon reservoir, North Dome. It's a continuation of the video from 12, which talk about the geology of North Dome and the development. So here we're going to concentrate on the gas to oil ratio in North Dome. North Dome is not actually just the largest gas reservoir in the world, but also the largest hydrocarbon reservoir. It has a mixture of quite some oil with gas. And then you will see that many maps have different gas to oil distributions. We call it gas to oil ratios in these maps. They're quite different from 1 to 1. And where to drill for the oil, more valuable oil, how to develop the field. And we'll show you that isotope is a very powerful tool to develop it. So here are some of the basic numbers of North Dome. It actually holds 500 billion cubic meters equivalent of liquid, 3 times the size of the world's largest oil field, GOR, in Saudi. But its GOR, the gas to oil ratio, barrels oil equivalent, is averaging 5 to 20 to 1, meaning there are a whole lot more gas than oil. So oil is only one half to 1/8 of GOR, which has a oil gas ratio of 1 to 3, which is obviously more oil. So to determine the exact ratio matters a lot to the economics of North Dome, and also the distribution is not homogeneous. Whether this distribution is a result of compartmentalization of the field, or the PBT will show you, which separate the oil and the gas due to phase stability at the reservoir pressure. So here I'm showing the isotope data at the drill, the wells, and the DST, which is the stem test during drilling. And this is a more accurate indication of the isotope of the C123 methane ethane propane. And this paper here in 2005, they're only to use type 2, which I have to say they're only because why? Because the Tmax, the other geochemical tool, eliminated type 1 marine type of lacustrine. So people can only use type 2 template, and when you use type 2, you end up with a maturity that's not very mature as you use type 1, I'll show you. But in geology deposition-wise, the oil of North Dome is believed to come from the early Silurian source rock. There's very little chance of type 2, which, is a known fact. But because Tmax eliminated the type 1, people have to use type 2, and they arrived at the wrong maturity. And then with the correct template, we put up a free app here. You can go to the website and put in the numbers and you run the maturity. And here you'll see that we put in the numbers, and we'll see that the maturity, if you use the red type 1, you'll see that actually they are in the range of 1.3 to 1.45. So this means the GOR, we have this template. It can also model the GOR, and you could see that the black is based on type 2, and the red is based on type 1, and they have the distribution of the gas oil ratio, okay? And you could see that if you use type 2, which is the black, you arrive then at the gas to oil ratio much lower than 1,000 cubic meter to 1, or lower than 6,000, 5,000 SCF per barrel, which is 1 to 1 almost. 6,000 SCF per barrel is 1. Okay. So this means if you use type 2, you arrive that this reservoir has similar amount of oil to gas, which make it a whole lot more oily. But in fact, it should be using the red, which means you have on average about 3 to 1 to 4 to 1 gas to oil ratio, and this is more realistic. And it's certainly lower than the 20 to 1, which significantly improved the economics of this North Dome South Pass. And you could also see that at the reservoir pressure, which is about 3,000 meters static water depth, or 3,000 bar, 300 bar, the most of the hydrocarbon will not be able to stably exist at the given original gas to oil ratio when they are generated. They will have to go PBT separation, either into oil or into gas. And during production, as the pressure drops, the separation will be even severe. So you need to know that which part of the reservoir is the gas cap, which part is the oil ring, and where to inject gas and how things evolve. And the isotope is obviously the most powerful tool. You can't use Tmax. Tmax only needs source rock, and it doesn't tell you what exactly migrated reservoir will tell you. Okay, so isotope is the key here. Thank you.